Everywhere you look, it seems like someone is building a new AI factory. Massive data centers rising from deserts in Arizona, cornfields in Iowa, and suburbs outside Dallas. Rows of gleaming servers, humming cooling systems, and endless power lines, all built to feed one thing: artificial intelligence. To the average person, these are just data centers, but inside the tech world, they've become the AI factories of the future, the industrial backbone of America's new digital economy. And here's the question no one can quite agree on: is the US building too many of them? Because while AI is supposed to make business smarter and life easier, the infrastructure behind it, the literal machinery that powers it, is beginning to look unsustainable. Let's start with what's happening. Over the past 18 months, the US has entered a full-blown AI construction boom. Microsoft, Amazon, Google, and Meta are spending record sums on new data centers, more than $200 billion combined in planned investments through 2026. NVIDIA is supplying the chips, construction firms are racing to keep up, and even cities that never had a tech presence are being transformed overnight. Iowa, Kansas, Georgia, Texas. Each one is now home to billion-dollar AI campuses. But these aren't small server rooms. They're sprawling industrial facilities consuming as much power as small cities. And that's where the cracks in the story begin to show. Because as the AI gold rush accelerates, it's colliding with three growing concerns: power, water, and economics. Let's start with power. AI computing is energy-hungry, far more than traditional cloud workloads. Every chatbot query, every model training run, every AI-driven service requires massive computational power. According to the International Energy Agency, global data centers could soon consume as much electricity as the entire nation of Japan, and the US leads that surge. Utility companies are already feeling the strain. In Virginia, the country's largest data center hub, power demand from AI projects has grown so fast that grid operators are warning of future blackouts. In Texas, officials are rushing to build new transmission lines to handle the load from data centers popping up around Dallas and Austin. Some of these facilities require hundreds of megawatts each, enough to power more than 100,000 homes. And while companies promise to offset it with renewable energy, the reality is more complicated. Wind and solar aren't always available on demand, and many AI data centers still rely heavily on fossil fuel backup. Then comes the water problem. Cooling these AI factories requires enormous amounts of water, not just for the systems themselves, but for the power plants that feed them. A single large data center can consume up to 1 million gallons of water per day, depending on its cooling design and location. That's becoming a flashpoint in drought-prone regions. Communities in Arizona and New Mexico are pushing back against new AI construction projects, questioning whether high-tech computing should take priority over local agriculture and water access. Some companies are switching to air cooling systems, but those require more electricity. Others are experimenting with recycled water, but that adds new infrastructure costs. No matter how you solve it, AI's physical footprint is anything but virtual. And that brings us to the economic question, the one that might decide how long this boom lasts. Are we actually overbuilding? Every major tech company insists these investments are essential, that AI will reshape everything from search to medicine to manufacturing, and that the demand for compute will be virtually infinite. But history says otherwise. In the early 2000s, telecom companies overbuilt fiber optic networks, convinced that the internet would grow even faster than it did. Now we're seeing echoes of that pattern in AI. Yes, demand for training models like GPT and Gemini is huge today, but what happens when the next generation of chips becomes more efficient, or when software becomes better at sharing computational loads? If AI growth slows, even slightly, some of these facilities could sit half-empty, consuming massive resources but generating limited return. Even investors are starting to ask tough questions. How many data centers can the economy support before costs outweigh benefits? Are we heading toward an AI bubble in infrastructure, not in software or stocks, but in steel and concrete? And perhaps most importantly, who pays for it all? Many of these data centers receive state and local tax incentives, billions in subsidies meant to attract jobs and investment. But the irony is that most of these centers employ only a few dozen people once they're built. They create huge demand for electricity and water, but not necessarily long-term local prosperity. Communities that welcomed AI factories are starting to wonder, are we trading resources for reputation? To be fair, there's another side to this story, one that explains why the boom continues. AI factories are becoming the core infrastructure of the digital era, just as railroads were in the 1800s or power plants in the 1900s. They're not just for chatbots. They'll power autonomous vehicles, healthcare diagnostics, advanced simulations, and national defense systems. From that perspective, building more capacity isn't wasteful, it's strategic. In fact, the federal government is starting to treat AI infrastructure as a matter of national security, funding new projects to ensure the US doesn't fall behind China in compute power. So are we overbuilding or future-proofing? The truth probably lies somewhere in between. Yes, some companies are racing too fast, building for hype instead of real demand. But at the same time, the US can't afford to underbuild either. If AI continues to scale exponentially, compute power could become the new oil, and whoever controls it will shape the next global economy. Still, this race comes with a warning. Just because the factories of the future run on code instead of coal doesn't mean they're clean, cheap, or sustainable. Every new AI server that comes online has a footprint, one measured not just in data but in megawatts, water, and environmental strain. So maybe the question isn't whether the US is building too many AI factories. Maybe it's whether we're building them the right way, efficiently, responsibly, and with a long-term plan for what happens when the next tech revolution demands even more. Because make no mistake, the AI boom is real. But like every boom before it, what matters most isn't how much we build, it's whether what we're building will last.